everyone, welcome back to another video. So we've got this big thing in this week. Right, so what this is a buck rake. This is designed for putting grass or silage into a silage clamp. So you'd have grass in a field, tractor with a mower on it, which would cut the grass, and then you'd have a forage harvester that chops the grass up and puts it into a tractor trailer, and then your tractor trailer brings it to the silage clamp, tips it out in a heap, and then the man on the silage clamp has one of these on the front of his tractor, on the front linkage, or on the back of his tractor, and his job is to scoop the grass up with this and then drive up the silage clamp and push it off and squash all the grass down into the silage clamp. So the way this works is this bit here is supposed to be, well, this bit travels backwards and forwards. So at the moment it's right to the extent of its travel outwards. So you'd have that back into there, and you'd scoop a big load of grass up, and you drive up the silage clamp, and then that bit will come forward slowly and push the grass off the front of the fork. So as it is now, it's just got a 3-point linkage brackets on it. So you'd either put it on the front of your tractor if you've got a 3-point linkage on the front, or on the back of your tractor. But the customers bought this and they want to put it on the front of the telehandler. So what I need to do is make some brackets to go on here so they can mount it on the telehandler or on the linkage like it is now on the tractor. I'm hoping, well, I think it should be the right width if I just cut some JCB brackets out, some Q-fit brackets, and weld them onto the side of here. We should be at the right centres. So I could just weld some in there and there, but I don't really want to rely on just this top box because I don't think that's very thick. You can tell by the corner radius it's not very thick. It doesn't sound very thick either. So I want to steal some of the strength off them brackets. So yeah, first job, I'll draw some brackets to fit in there. I'll have to avoid them holes. I'll have to either make the bracket go around the back of them. I won't be able to actually because the bottom locking pin needs to be here somewhere. So yeah, I'll have to go around them holes. Right, so I've got that drawn. I think I'm just going to cut it out with some 3mm first to make sure we're right. Make sure them holes in the right place so you can still get the pin through. Right, so that bottom bit isn't far off. I can sort of make do with that. So I just need to notch a little bit out of that bottom corner there, where that tine is. But I've forgotten about that bit in the middle sticking out so far. So this top hook needs to be right out here. So I'll have to alter that bit. And then the bracket's sort of going to be looking back on itself, so I might have to bring this bottom hole out a little bit as well. But that won't really matter too much. But and it was a little bit tight in there. I had to grind a bit off to get it to fit in there. But other than that, should do the job. So yeah, I'll do them alterations now, and then I think we'll cut the brackets out at 25mm. Right, so I've got that bracket redrawn with the alterations, so the top hook's further out. It's a bit missing around the bottom. So yeah, that should be right. So I'll bring some 25mm plate round and put some 25 on there. I would have usually cut a bracket like this out at 30mm, but I haven't got any in stock at the moment. So 25mm will do. I'm going to flame cut it out as well. I can cut 25mm with this plasma, but it's I'm just a bit short of electric, and it's not always that reliable. Cutting 25mm soon runs out of power, seems to do. So we'll gas cut it. So I don't think I've shown you this feature before, but on the Katava software it has an add-on that you can use, that it tells you the price of like each part you cut out. So that bracket that I cut out there are 3mm with a cost £9.83. But if I'd have cut it out at 25mm plate, it would have cost £103.49. So it's definitely worth doing a test out at 3mm first, because if that was wrong and it was 25mm, it'd have been very expensive. I've just changed it to oxy-fuel cutting. Oxy-fuel cutting would have been £83.15, so it's actually cheaper cutting stuff with oxypropane than it is the plasma. So we're all set up, should be good to go. We get 2 out of there, sort of working around what's already been cut out. But I'm going to flame cut all the holes out as well, save a bit of time. So yeah, we'll get it lit up and get them cut out. Right, so got that sat in there, still a bit hot. There's a few bits I need to grind off it, so I need to grind off down on the inside so it'll fit around that weld. It's a bit to grind off there, and then same on that inside, I'll have to grind a bit off. I'm not quite sure how well these holes are going to line up. One, I can get 2 to line up with that 3rd wheel, I'm not sure. It wasn't the easiest thing to measure because I was sort of measuring off there. But then these holes don't really seem square with that. They seem on a bit of an angle, so it wasn't the easiest thing to measure. But yeah, I'll take that back out, give it a clean up, dress it up. I'll have to grind around here as well, grind all the paint off, and then I'll weld it up around there. And then I purposely put that bow in the back there so I can then get a good weld up the back of there, around there and underneath. Yeah, I'll stick that on them trestles, dig that other one out, sit it on there and then give them a clean up. Right, so I've got this bracket clamped back in here again, and I have just made a bit of a balls up with these holes. They just don't line up properly. Middle one does, but then that one's a bit out, and that one's a bit out. I could just put a different pin in, it wouldn't really be a problem, but ideally I want to be able to put these pins back in again. They've got like a shoulder machined on there, so it fits the middle. It's not the others. So I think I'll see if I can chop a bit more out there just with a hand torch on a plasma cutter. It won't look as good, but I think that'll be the easiest and best way to sort it out. And there is a little bit of a gap there, but I can fill that with weld. We've got plenty of clearance down there to miss that top link bracket, well, enough clearance anyway. Right, so they all do fit now. They don't look very good. I'm a bit annoyed that I've had to do that, but at least that pin, the standard pin, fits all three holes. So I'll have to give them a bit of a clean up with a die grinder. And you won't notice so much. And then I'll have the same to do on the other side, I think. Yeah, so this bracket wants exactly the same. Middle one fits, top and bottom just want a little bit taken out of them. So that's both of them fitted on now. So you can barely tell I've altered them holes when you're looking at it from this angle. When you're looking at it like straight on, you can tell. But it's not really an issue. It's it just more for looks than anything. So yeah, that's all on. So there's a bit of a gap there to fill, but that's not a problem. Ideally, them brackets wanted to be on an angle, but I can't get the hook any closer in because of the bit in the middle. Your carriage would hit on that. So I'd have to move that bottom hole out. So the bottom hole would have to be sort of out here somewhere, but then you're at risk of it catching on the front wheel if it's on a front of your tractor if you're turning, or it's going to be, you know, when it's out there it might catch your back wheel, so it's sort of just having to do it like that. But they should be fine. You just when it's at ground level you won't have much crowd back. You'll have to sort of lift it off the ground a bit before you can get any angle on the tines, but can't really do it any other way. So yeah, I think I can tack them on now. Now when you measure the bracket centres as well, we're bang on, and near enough bang on 41-inch centres, which is what I usually put JCB brackets on at. So yeah, we're good at that. Right, so to weld it up, I'm going to weld it up in the position it's in now. Usually for stuff like this I'd move it or turn it over so you're welding on the level, but because it's such a big thing it's going to be real high to weld it level, so I'm going to change wire. I'm going to have a go with this. I've never used this before. It's a Cabelco DWA50, so it's a flux cord wire, which is a lot easier for welding vertical up with a flux core, so we'll have a go with that and see how we get on. It's 1.2 mil, so I'll have to change the rollers, obviously change the wire, and change the nozzle, change the tip. So I've had 2 electric meters fit in the workshop, so just out of interest I'll take note of what the meters say now, and then when we weld that up we'll check again and see how much electric we've used welding them brackets on. There's 2 meters because there's 2 phases, so we've got 11.2 kilowatt hours on that one and 3.01 kilowatt hours on that one. I'll check again once I've got this welded up. Right, so that's all that welded up. It's just you can sort of run straight up, just like you could if you were on the level with it. I sort of did a bit of a weave there. It looks, depends which light you look at it in. Apart from, I've just noticed on this bit there is a few little like wormholes, so I'm going to gouge that bit back out and re-weld that bit. But the rest of it has gone really well. Now on 4.56 on that one and 12.97 on that one. So I've gone back over that bit. That's better. There ain't any wormholes in it now, I don't think. So yeah, that's all that welding on. This side, I did a bit of a weave up that side, so that's sort of a fatter weld than what I did at the other side. The other side I just sort of ran it straight up. This wire, it has been sat on the shelf for over a year, so it might have got a bit of damp into it. That's maybe why it was causing them wormholes. But yeah, there's more than enough weld holding them on now. See, they're welded down both sides and around the top and bottom. So it's only like 4mm box it's welded to anyway, so it's as strong as it needs to be, or strong as it can be, I think. I'm using MIG Weld 20, which is pure argon and 20% carbon dioxide. And then about 15 litres a minute. So I'll just give it a coat of paint now. I'm going to go over it with red oxide first, then we'll go over it with black after. I don't fancy getting my spray gun out, so I'm just going to aerosol it. Right, so I've just been having a play with this dual shield wire. I've turned the gas up to 25 litres a minute and I've got no problems there with what is it, the wormholes. So I think I didn't have enough gas to start with, that's why I was having bother. So that's that finished, so that can go back out now. So I needed to get that done this week because I want to use it tomorrow. So now I've got that done, I can get back on with this jig and them crankshafts that I was on with last week. That'll probably be next week's video. So yeah, that's all for this week. Thanks for watching, hope you enjoyed the video, and I'll see you next time. Before you go, just wanted to say there's some more Snowball Engineering hoodies back in stock. So there's the usual hoodie type, then I've also got some zip type ones available as well. Yeah, so these ones are same thing, embroidered on the front, and then the logo is printed on the back. A few people are asking for zip up ones, so I've got some of them as well now.